to class. So last class we had discussed about what is deployment object, and so there is right, deployment object is the recommended way to create your parts, deploy your parts, and so parts are replica set. So these are the advantages. Already last class we seen, right? Deployment as a replica set and update parts, roll back to older deployment version, and if you want to we can scale up, if you want to we can scale down, and if you don't want we can clean up also. So these are the mostly we are using, these are the how to roll out, how to scale up, kubectl scale, deployment name and all. So first come to here, let me open. Last class already we seen, right? Go to here, where is our path? C column users HPs practice. Okay, here. Okay. So now if you see here, kubectl get parts. So kubectl get parts. So do we have any? Nothing is there, right? Now, so where is that? So dir, and this is the deployment recreate and deployment rolling update. So if you are not mentioning anything, what is the default deployment? Rolling deployment. So if you are not mentioning anything, so there is two types of deployments, right? So deployment strategies. First one is rolling deployment and the second one is recreate deployment. Now we'll see practically how will it work. Rolling means once a new version is ready, older version will be deleted. That is the behavior here. See here, it works slowly one by one, replacing parts of the previous version of your application with the part of new version without any cluster downtime. If new version is ready, older version will be down. Otherwise, the older version it won't down. And so recreate means, see here, the older parts are killed all at once and they get replaced at all at once new ones. So automatically it is kill the older parts and replaced by new parts. That's it. If you are understanding these two lines, that's enough. Now we'll see practically how it will work. Now, so notepad rolling deployment hyphen so recreate. I'm using recreate. Recreate means once a new version is ready, older parts will be deleted. Older parts will be deleted. See here, remaining store same only. KPI version and deployment, and this is the replicas. How many replicas I am using? Two replicas, two parts. Here type equal to recreate. Type equal to recreate. So here they are. We are working on which one? Recreate or rolling update? Rolling, right? First we'll see rolling. Okay, notepad, deployment, recreate, rolling means rolling update. Now see here, here I am mentioning so rolling update. This is rolling deployment. What is rolling means? New version is ready, older parts will be deleted, otherwise it won't deleted. Okay, just try to understand. Remaining story same only. So type equal to rolling update here, maximum surgery and maximum unavailability 1. So these are the extra things we need to remember. Rolling update means, so here what is rolling update? Max, how many you want? 1. Max unavailable also 1. And so remaining same only, selector label under nothing, and this is a service object. Here only we have to understand rolling update, maximum and max unavailable, maximum search and maximum unavailable. So these are the rolling update. Extra only two tags we need to add. Okay. So these are the rolling update allows deployment update to take the place zero downtime. Without downtime, if you want to deploy, that case we can go for default one is rolling only. So it does by the incrementally replacing the current parts with new ones. The new parts are scheduled on the nodes with the availability resources. So how it will work means, so here we need to use, so these are the update. Rolling update allow deployment update to take place zero downtime, and see like this. See here new pod, update application and service also it will update. This is the deployment, this is the service object, and these are the IPs. Now here if you go to here get pods and all, now example where is here then pods and all undo deployment, not example Kubernetes deployment. Now see here, so these are the strategy, type equal to rolling update and maximum unavailable one. So what is it meaning here? If you go here processing min ready seconds, and so revision history limit passed. Here some rolling update deployment example use min update. Now see here what is max surge is an optional field that specifies the maximum number of parts that can be created over the desired number of parts. That is the maximum surge. So here we are using right max. What is this max surge? Max search means, so how many parts? How many parts? See here, this is the optional only. Maximum number of parts that can be created over the desired number. And so the value can be absolute number. Example 5. The percentage of desired parts. Example 10%. The value cannot be 0. The maximum available means is 0. The absolute number is calculated from the percentage by rounding up. The default value is 25%. So these are the what is min, what is the maximum. So for example, when the value is set to 30%, the new replica set can be scheduled up to immediately when the rolling update starts. So that's such that the total parts does not exceed more than 130%. More than 130%. That is the desired state. Once older parts have been killed, the new parts can be scaled up further. Ensure that the total number of parts running at any time during the update is most 130 of the desired parts. So this is the maximum honorable and maximum surgery. Maximum number of parts that can be created over the desired number of parts. So available means, so this is a minimum one. Minimum we are using. So 0 to whatever we want we can set that. So that is the these two numbers. Now if you observe here, now I'm going to execute this thing. Now I don't have anything. Now see here how it will create. CLF kubectl dir kubectl apply -f deployment deploy -rolling. Now, so first time, so there is two parts, deployment 2 and one service object. Now check it, kubectl get parts. Now I have two parts. These two parts are running. These are the just now I created, right? And so observe here, kubectl get parts, get all. Now one service object, this is the deployment, update and replica set desired, current, ready and 19 seconds ago. Now again I am going to change the version. Again I am going to change the version. Now try to understand. Right now these are the parts, two parts running, everything working fine. There is no issues. So this is the local host. If you want to, we can check here also. See here, local host. Now everything working fine. Now we can see Tomcat and all, and we can see Maven web application also. Everything working fine. Everything working fine. Now what I am going to do? I am going to change the version. I am going to change the version. Now same thing I am going to update. Notepad, rolling update, rolling, sorry, edit, right? Add notepad, rolling update. Now here I am using so Maven web application, right? So instead of Maven web application, I am going to use so different application. Here I don't have any other application. I will change this image. First I need to check what is my image. Hub.docker.com. app.docker.com, sign in. So in this image, I have only version tag number, only one is there. I need different version tab. That's it. I don't want Maven, Maven web application. Or else we can take this one also. Spring Boot Mongo. Spring Boot Mongo. What are the tags? Now here also latest one. And what is that latest one? I need multiple versions just for testing purpose. I think Maven web application. So here many tags is there. I am going to update this one. Now I can easily update anytime. So see multiple tags available here. Now go to here. I am going here. Just update here, and so here, for example, what is the tag? I am using anything. For example, 200. I am using tag number 200. Control S. Apply. Save. Apply. Save. Now understand. I am going to delete the existing and all. kubectl kubectl delete all hyphen all. I don't want all. Now again I am running. Right now I don't have anything. Understand. kubectl get parts. I don't have anything. kubectl apply hyphen f deploy hyphen recreate. Okay, not recreate, rolling, right? Rolling. Okay, first check it. Notepad, notepad, deploy hyphen rolling update. Okay, now updated, right? Everything correct. Now let me execute kubectl apply hyphen f file. Now this is created. Now check it. So now how it will work? kubectl kubectl get all. Now see here how many parts are running? Two parts. Now go to browser. Go to browser. Just refresh it. Okay. Now so go to browser colon kubectl, clear the screen, kubectl get svc. So what is this? Local host only, load balancer. So localhost slash Java web app. So Java web app. Now this is the context path. My context path is this one, Java web app. Java web app. So now my application is running. Now what I am going to do? This is the older parts, right? Now I am going to deploy new version. Now I am going to deploy new version. So how to deploy new version? Now try to understand. Here I go to here. Again I am updating. I am changing to 199. This is the R201. This is a new version. So this is the new version. Control S, file, save. I am redeployed. New version. Now try to understand. So I need two screens, right? How can I watch? Watch command. Okay. First, kubectl, kubectl get parts, get parts. kubectl get parts. CLS, kubectl get parts. Now these are the two parts. Now I am running same new version. New version. Now see here deployment rolling update kubectl apply kubectl apply hyphen f. Now kubectl get parts. Now see here this is the 10 in seconds, right? Now 3 seconds ago, 3 seconds ago already older. This is very simple application, right? This is a very simple application. Now if you observe here, so this is the older parts 4ml and so 8wj. Do we have any parts here? Do we have any parts here? Now see here new parts updated. New parts updated. So in this case what is happening? If new part is ready, older parts is deleted. New parts is ready, older parts is deleted. So that is the concept here. This is the rolling. Rolling means once a new part is ready, older parts will be deleted. Once a new part is ready, old parts will be deleted. This is the rolling update. So this is the rolling update. Clear guys? So we need to add. So this is the rolling update. Maximum how many parts you want to maintain. Maximum availability also 1. Now same thing I am going to create so new one. I am going to create recreate. Recreate means what is happening here? What is happening here? Now we can open one more also. Watch one more command. Parallelly, I am going to open. We can get something. Go to here. User HP. Where is that one? Practice here. CMD. Okay. Now go to here. Now I'm opening a parallel also. We can do fourth. Now go to here. Okay. What is that command? Watch command. Need
Watch kubectl. Watch kubectl
watch
get parts.
watch cube CTL get parts. Watch cube CTL get.
Kubectl get parts.
I think watch is this is a local mission, right? It won't
Yes,
work.
it is not working. Yes,
It
yes,
won't
yes,
work.
yes.
Okay, okay. So that something else. So if you want to, we can watch leave it. So this is the command. If you want to check, so whether how many seconds it will take, it is creating or not. So we can check with the help of watch also. Now anyway, I'm going to use one more one. kubectl kubectl delete all hyphen all. Now I'm going to use which is that one. Second one, which is that one? Second one is recreate. Recreate means so how it will work. Recreate means immediately it will delete the older parts and it will delete older parts and it will recreate the new parts. kubectl kubectl first open notepad deploy hyphen recreate. Now in this case, type equal to recreate. That's it. No need to mention anything. Type equal to recreate. Type equal to recreate. Type equal to recreate means so immediately existing parts will be killed and new parts will be redeployed. See here, all old parts are killed immediately. All of the old parts are killed at all at once and the get replaced all at once. The new ones is come. So immediately it will kill the old parts, replace it by new parts. That is the behavior of recreate. But in this case, slowly one by one. If new part is ready, older part will be deleted. Once new part is ready, older parts will be deleted. That is the behavior here without downtime. So in this case, not like that. At a time, all of older parts are killed. Automatically, it will replace it by the new parts. This is the behavior of so recreate. Remaining same only one line only. Type equal to recreate. But in this case, rolling update type equal to rolling update and rolling update maximum search and maximum availability. How many parts you want to maintain? That and all we need to maintain here. That and all. So here right, what is maximum means? What is the max means? What is the max means here? Max unavailable means is the optional field that specifies number of parts that can be available unavailable during the updated process. So that and all we can add two things. We can add two things. This is also max search. So this is the maximum number of parts that can be created over the desired number of parts. Over the desired number of parts. Now I am executing same thing. kubectl 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 apply hyphen f hyphen f hyphen f deploy recreate. Now two parts are running. kubectl, kubectl get all. Now see here, two parts are running. Now I'm going to update my version. I'm going to upgrade my version. Now see here, I'm going to update same thing. Now this is the 198. Now I'm going to update 20, new version. File, save, file, save, file, save, file, save, and go to here. Now this is what is this? This is the older parser. Now I'm running same command. Now observe here, kubectl apply rolling update, not rolling update, recreate, right? Notepad, recreate. So kubectl, kubectl, kubectl apply, kubectl apply hyphen f deploy recreate. What is happening in this case? Automatically it will delete all existing parts, all the older parts will kill and replace it by new parts, replaced by new parts immediately. Now see here, configure kubectl get parts, kubectl get parts. Now observe here, kubectl get parts. Now see here, so what is this part? Pnd kzp, do we have that part? No. Automatically killed older parts, replaced by new parts. That's it. That is the behavior of recreate, very very important. Interview also they are asking us which deployment strategy we are following in Kubernetes. Okay, rolling deployment and recreate. Rolling means slowly, one by one. Once a new version is ready, older version will be deleted. But if you come to new recreate, at a time it will delete all older parts, will kill it, replace it by new parts. That's it. Apart from this, no need to remember anything. Clear, guys? I hope you got some idea, right? Now coming to here, there is one more. What deployment strategies? Blue and green deployment. This is also very very important. Blue and green deployment means there is interval also. This is also very very important. No, MS Paint. Blue and green deployment. Blue means green. Now try to understand. So this is the green and this is the blue. This is the, just assume this is the green deployment, this is the blue. Okay, now go to here, go to here, this is the green. Green means, this is the green means running, working fine, there is no issues. This is the green, this is the blue. Blue means new version, this is the blue. Blue means a new version, this is the new version. Blue means new version, new version. This is the running version, this is the running version, this is the running version, this is the new version, this is the running version. So this is the container, this is the pod. Okay, so this is also new pod, this is the new pod, this is the new pod. Okay, new application. Now if you try to here, this is also very simple. See, blue and green deployment strategy. The older version of the application green. So older application means this is a older application, nothing but older means running application. Older application. Older application is nothing but this is the green. New version means this is the blue. Now what is happening here? And so new version means glue get deployed at the same time, when both of these are deployed, users have only access the green. So we are giving access only end users, this one only, we are giving access only this one to end users, we are using only this one to end users. So who are accessing, this is the end user. End user means user, users access only green. If we deploy new version, first, we are assigning to, this is the UAT team. We are assigning to UAT team. We are assigning to UAT team, user acceptance team. Directly, we are not giving UAT, user acceptance. This is the UAT means user acceptance test. And so once they sign it off, we are assigning to UAT team. Once they tested, if everything working fine, next we are removing this endpoint. We are giving endpoint to new version. That is the behavior here. See here, when the both of these deployed, users have only users users only have the access the green. Green means this is the working running application. There is no issues, no zero error code. Everything working fine. Now what is happening here? See here, blue now. And so the blue is available. The QA team for the test automation or separate version via port redirection and all. See, after new version has been tested, after see blue version is available for QA team only. Once QA team is quality assurance team, they tested everything working fine, then sign off for release, then service is switched to blue version with the older version being scaled down, being scaled down. Now got it? So there is two versions. This is the green, this is the blue. So green means customers are accessing this version. Now if we deployed any new version, directly we are not giving access to customers. First we are assigning to UAT team, UAT, user acceptance, UAT, that is a quality QA team, quality assurance team. This is the QA team, quality assurance. Once they sign up, once they accepted, now slowly we are removing endpoint this one, older version, and we are giving new version. We are giving access to users to new version. That's it. So that is the blue and green deployment. This is nothing but blue and green deployment. Blue and green. Blue is nothing but a running application, older version. Sorry, green means older version. Blue means new version. So usually end users are accessing green only. Now if you deployed any new version, that is blue, that we are assigning to QAT team, quality assurance team. Once they sign up, and slowly we are removing the endpoint folder, that is green, and we are giving access to new version. So this is the blue and green deployment also. This simply we are calling red and black also, red and black also, red and black also. I hope you got it right. So anyone any doubt here? This is the interview also. Many people they asked what is blue and green deployment. Green is nothing but running application, existing version. Blue means new version. So new version directly we are not giving access to a customers. Once blue is ready, slowly we are removing endpoint to green and we are attaching to new version. That's it. Okay. So that is the deployment. So now if you want to create any pod, which is the recommended way, which is the recommended object in Kubernetes, if you want to create any pod and all, deployment object. Right, many objects, pod, pod. So as of now, right, this is the pod. Next, pod. Next, namespaces. Next, RS replica set, RC replication controller. Next, service object. Next, deployment. Next, demand set, DAE, demand set also, demand set. Now, which is the recommended object? If you want to create pod, which is the recommended object? Deployment is the deployment is recommended object to create your pods. We can create with the help of pod also we can create pod. With the help of replica set also we can create pod. With the help of replication controller also we can create pod. But compare to all, so many features available in which object? Okay, so this is the recommended way. If you want to create any pod, which is the recommended deployment object. So right, we can easily scale up, we can easily scale down, and we can roll back to previous version. We can see history also, we can check the status of deployment status also, we can check it. There is many features available in deployment object, and that is the reason in real time if you want to deploy, if you want to create any parts, so mostly we are using deployment object. And replica set and replica controller is the, so this is the managing pod life cycle. These two are managing pod life cycle. How many parts, desired parts, required parts. So that and all meaning with the help of replica set, replica set only. Okay. So that's it. So these are the deployment. I hope all objects almost we cover. Now go to here. There is one more I will going to cover. That is volume concept. This is the volume concept. So this and all will cover this ingress and all already in Monday onwards. So sir will cover some of concept in AWS. And so today we'll see what is volume in Docker. Right, in Docker, if you go here, Docker, volume concept. What is the purpose of Docker volume? In Docker we are using, right? So volume concept. What is the purpose of Docker volume? Persist your data permanently. Or simply if you want to take, what is this? Backup. Simply if you want to understand, backup, right? So this is my container. Unfortunately, your container is deleted. How we are maintaining? So we are maintaining backup, right? I need data. So this is my doc. I created one container with the help of Docker. Now, unfortunately, this the container is deleted. What about my data? You lose your data, right? So to overcome that problem, so in Docker there are a volume concept. With the help of the volume, we can to maintain persist your data permanently in our host file system, in our host. Same concept. If you come to, this is the Docker. This is the Docker story. So this is the Docker story. We are using so Docker means that is a volume. If you are using Docker means up to Docker Docker. In Docker we are using volume concept. We are using volume. Now, same concept if we come to Kubernetes. If we come to Kubernetes, so here we are calling, see here, Kubernetes volumes. Kubernetes volumes. Okay. Here we are using -c, right? -v. We are while creating the container, we are attaching something, right? Same, you know how to create containers and all. See here we are using Docker run -it -v. We are using -v. This is the volume path. This is the volume path, volume path, and :/container path. We are using container path and image name. Correct? This is the syntax in Docker wise. So this is very simple. Same concept if you come to Kubernetes. Kubernetes here also we are using volumes. We are using volumes. We are using volumes. We are using volumes. Now, if you go here, here there is two types of volumes. They see here if you come to here, there is many volumes. Persistent volumes, there is static volumes and dynamic volumes. So these are the new terminology we need to try to understand. So there is static volume. Static volume means every time fixed static volume. Static volume and a dynamic volume. Dynamic volume. Static volume and dynamic volume. And here also there is a PV. PV, persistent volume, and a PVC, persistent volume claim. This is the PV and PVC, persistent volume claim. Persistent volumes, there is two types, PV and PVC, persistent volume claim. CLAIM claim. So these are the new terminology, try to understand. So static volume and dynamic. So static means manually we are going to create. Static means manually we are going to create. We are going to create. Dynamic means automatically it will create. Automatically it will create. Now there is two types of volumes, so PV and PVC, persistent volume and persistent volume claim. If we go here, we need to understand few things. Now there is some policies also is there, claim policies, retain policy, recycle policy, delete policy. So retain policy, recycle policy, delete policy, recycle policy, delete policy. Now see here, so value means same concept. Persistent volumes are simply piece of storage in our cluster. I want to store data. If you want to store data, if you want to store data, so we are going to use persistent volume. This is PV, persistent volume, and PVC, persistent volume claim. Similarly, how to have a disk resource in our server. Persistent volume provides storage resources for objects in the cluster. So what PV will do? PV will provide the resource, storage. It will provide storage only. Now, if you go to persistent volume, parts that need access the persistent storage, right? I need access this volume. I need to access this path, storage path. So that case we are using PVC. Obtain the access through the use of the persistent volume claim. But PVC binds the persistent volume to the pod requested as. So how it will work? Work means if you go here, PVC, PVC volumes, persistent volume and persistent volume claim. Now if you observe here, this is if you understand this is very simple. If you understand this is very simple. Now see here, where is the diagram? Not this one. Now if you go here, see here, this is the physical storage. This is a physical storage means your hard disk, right? This is a physical storage. This is the physical storage means your hard disk. This is the physical storage. This is the physical storage. So this is the physical storage, and physical storage top of we are using PV. PV interact with the, this is my application. This is my pod. This is my pod. So this is my pod. If you understand here, this is physical PV PVC application. So now here, this is my application. Application nothing but right? So this is the application, my pod. This is my pod. So inside the pod only container running. I hope right? This is the application. So this is my application. Yes, see. This is my application. This is my application. Okay. So now application interact with the PV, PVC, persistent volume claim. Interact with the PVC, persistent volume claim. Interact with the PVC, persistent volume claim. This is the PVC, PVC. PVC interact with the PV, persistent volume. PV interact with the persistent volume. PV interact with the persistent volume. Persistent volume interact with the physical. This is the PV, persistent volume. Persistent volume interact with the physical, same seed, physical storage. This is your physical physical storage. This is your physical storage. This is my this is our physical storage. This is our physical storage. This is our physical storage. Now, so this is my application. Simple application where it is running. This is a pod, right? Blindly don't confuse here. Your application running container. Where is container? Container inside your pod only. Correct? This is your pod. This is your pod. So inside pod my application is running. Now I want to maintain my data. I want to maintain my data. So I want to maintain, I want to save my data. So permanently, I want to persist my data in my storage. So this is the application. Application interact with the PVC. PVC interact with the PV. PV interact with the, your physical storage. This is the flow. This is the flow. Now if you go here, first you need to understand. See, piece of storage in our cluster. I have some data. I have some data. How to store this data? I want to store my data. Where we need to store? So we need to store into the PV only, persistent volume claim. PV. This is the persistent volume. This is the persistent volume claim. So parts that need access the persistent storage. So what will do? PVC will interact with the PV, and PV have some data, right? That path obtain the access through the set of persistent volume claim. We are getting access with the PVC only. Now here there is two ways we can create. One is static and one is dynamic. A static persistent volume simply means some Kubernetes administrator provisioned persistent volume in the cluster. So now I need some storage. For example, this is my application. This is my application. For this application, I need some storage. I want to store my data. You are interact with the administrator. The administrator they will create manually. They will create manually. This is nothing but static volume. This is nothing but static volume. So this is my application. For this application I need this is my application. For this application I need some storage. I need some storage. Who will create that storage and all? Administrator will create the storage. Administrator will create the storage. This is the static. Now there is one more concept is there, dynamic. Dynamic means some circumstances pod cloud requires persistent volume that does not exist. So based on your requirement, I want to create dynamically. So in those case, it is possible to create, it is possible to have Kubernetes provisioning the volume if needed. If storage class were configured to determine where the dynamic PV should be built. This post will focus on the static volume now. Now simply understand, if we create manually, if administrator create your storage persistent volume and all, that is nothing but static. So if you don't want create manually, if you don't want create manually, and so I want to create dynamically. So that is nothing but dynamic value based on your requirement, based on your requirement, automatically it will create a volume. That is the dynamic volume. If we configure administrator manually, we are requesting something. I need 50 GB hard disk. What they will do? So I am requesting admin team. I am requesting, for example, 20 GB space I need. So if you request that PV interact. So if you request and PVs will request PV and PV will and administrator will key the create this space and all. This is the static. So suppose if you want to dynamic, we can configure dynamic also. We can configure dynamic also. Now here also there is some policies also available. This is very important. Policies. So see here claim policies. There is three types of policies: retain policy, recycle policy, delete policy. Okay, these are the three types of policies: retain policy, recycle policy, delete policy. So delete means this is the default one. This is the, so when a claim is deleted, it removes the both persistent volumes object from the Kubernetes. Now I have two, right? Now I have two. PVC also is there, PV also is there. If you delete the, if you policies, if you mention delete, delete means once if you delete that object, automatically all will deleted. Which one will deleted? PV will delete and PVC also will delete. So as well as associated storage also it will delete. Now there is recycle. Recycle means you know, right? Someone is reusability. Recycle means reusability, right? So when the claim is deleted, now see here, when the claim is deleted, the volume remains but perform basic scrub, delete data from the storage and on the volume and make it available again for new claim. If someone is reuse it, if someone is reuse it, now there is a retain policy. Retain means when the PVC is deleted, PV will still exist. PV will still exist and the volume is considered released, but it is not yet available for another claim. No one cannot use. No one cannot use. Now got it? This is a retain policy. These are the retain policy. There is three types of policies: retain policy, recycle policy, delete policy. If you delete if the claim is deleted, automatically it will remove the both PV and PVC. Recycle means if your claim is deleted, okay, so volume remains but perform the basic rub operation. And this is the reusability. Someone is can use it. Retain policy means PVC deleted but PV still existing and that cannot use anyone. That cannot, the administrator can manually claim the volume. Only administrator can manually reclaim the volume. These are the three types of policies. So this is a new terminology. Try to understand. Try to understand persistent volume for PV. This is simply we are calling PV and PVC, and these are the claim policies. And there is two types of volumes: static volume and dynamic volume. Static volume and dynamic volume. Okay. So now next class I will show you so how to create these volumes and all, how to create these volumes and how it will work. How to create a static volume and how to create dynamic volume and how to use this and all. Okay.